Ever wondered why cancer is so hard to beat? It's a question that has puzzled scientists and doctors for generations. You see, cancer isn't a single entity but a collection of diseases, each with its own unique characteristics. It's more like a shapeshifter, constantly changing and evolving, making it an elusive and formidable adversary. At its core, cancer is an abnormal growth of cells. Our bodies are made up of trillions of cells, each performing a specific function. But sometimes these cells go rogue. They start to multiply uncontrollably, invading and damaging healthy tissues. This is what we call a tumor. Not all tumors are cancerous, but those that are pose a great threat to our health. The complexity of cancer goes beyond rogue cells and tumors, though. There are factors like genetic mutations, environmental triggers, and lifestyle choices that can contribute to its development. But why is cancer such a formidable enemy? Let's dive in deeper. To comprehend the difficulty of beating cancer, we must first understand what cancer cells are. Cancer cells, in essence, are our own cells that have gone rogue. In a healthy body, cells grow, divide, and die in a controlled manner. This process is regulated by the DNA within each cell, which contains the instructions that dictate the cell's behavior. But when these instructions get corrupted, which can happen due to a variety of factors, cells may start to grow and divide uncontrollably. This abnormal growth forms a mass of tissue we commonly call a tumor. Not all tumors are cancerous, though. Benign tumors are those that don't invade neighboring tissues or spread to other parts of the body. They are generally not life-threatening. Malignant tumors, on the other hand, are what we typically refer to when we talk about cancer. These are the troublemakers. They can invade nearby tissues and organs, and even break off and travel to other parts of the body through the blood or lymphatic system, a process known as metastasis. Cancer cells are deceptively clever. They can trick the body into thinking they are normal cells, thereby avoiding detection and destruction by the immune system. Furthermore, they can coerce the body to provide them with the nutrients and oxygen they need to grow and survive, effectively hijacking the body's resources for their own nefarious purposes. What makes cancer cells particularly dangerous is their potential to cause significant harm to the body. They can disrupt the normal functioning of tissues and organs, starving them of essential nutrients and oxygen. They can also cause inflammation and put pressure on nerves, leading to pain and discomfort. In severe cases, the damage caused by cancer cells can be irreparable, leading to organ failure and ultimately death. Now that we've seen what cancer cells are, we can start to understand why they're so tough to combat. Cancer is not a single disease, but a collection of related diseases. A profound statement that underscores the complexity of cancer. Picture this, if you will, a library full of books. Each book represents a different type of cancer, and within each book there are chapters, paragraphs, sentences, and words, each representing the unique characteristics, behaviors, and mutations of that specific cancer type. Now consider the sheer number of books in this library. There are over 200 different types of cancer, each with its own unique set of challenges. From the well-known ones like breast cancer, lung cancer, and prostate cancer, to the less common ones like pancreatic cancer, ovarian cancer, and brain tumors, each one is a unique entity requiring a different treatment approach, and it doesn't stop there. Even within the same type of cancer, there can be numerous subtypes, each with its own unique genetic makeup and behavior. For instance, breast cancer isn't just one disease. There are several subtypes of breast cancer, each with its own unique characteristics and treatment requirements. This diversity is a significant part of what makes cancer so difficult to combat. The vast array of cancer types and subtypes means that a one-size-fits-all solution is simply not feasible. Each type of cancer requires its own specific treatment approach, tailored to its unique characteristics and behavior. Moreover, the treatment approach for an individual patient can be influenced by a variety of factors, including the patient's overall health, age, and the stage and aggressiveness of their cancer. This adds another layer of complexity to the already challenging task of treating cancer. In essence, the complexity of cancer is not just about the sheer number of different types and subtypes, but also about the intricate interplay of various factors that influence how each type of cancer behaves and responds to treatment. The myriad forms of cancer add another layer of difficulty to finding a cure. With every new discovery, we move one step closer to understanding this complex disease. Yet the journey to a cure is a long and winding road, fraught with challenges and setbacks, but also filled with hope and the promise of a brighter future. One of cancer's deadliest traits is its ability to hide from the body's natural defenses. Just as a chameleon blends into its surroundings to evade predators, cancer cells have the uncanny ability to disguise themselves in order to elude our body's immune system. This is known as immune evasion, and it's a major reason why cancer is so challenging to combat. Normally, our immune system is a vigilant guardian, continuously scanning our bodies for threats like viruses or bacteria. When it detects these invaders, it swiftly mobilizes an army of white blood cells to neutralize them. However, cancer cells, despite being abnormal, originate from our own body cells. This makes it challenging for the immune system to recognize them as threats. To further understand this, imagine a bustling city where everyone is wearing the same uniform. Spotting a rogue element becomes almost impossible. Similarly, cancer cells wear the same uniform as our healthy cells, effectively becoming invisible to our immune system. But the deception doesn't end there. Cancer cells also have the capability to send out false signals that trick the immune system into thinking they're harmless. They can emit chemical messages that dampen the immune response, allowing them to grow and multiply unchecked. It's as if the cancer cells are whispering sweet nothings into the ear of our immune system, lulling it into a false sense of security. Moreover, some cancer cells can even hijack immune cells and turn them into their allies. Instead of attacking the cancer, these corrupted immune cells protect the tumor and promote its growth. It's a classic case of the fox guarding the henhouse. So, not only can cancer cells camouflage themselves and send misleading signals, they can also manipulate the immune system to their advantage. This crafty trio of tactics allows cancer cells to thrive and spread throughout the body, making them a formidable adversary. Understanding this ability of cancer cells to dodge the immune system is crucial in developing more effective treatments. If we can find a way to unmask these stealthy invaders, we can equip our immune system with the tools it needs to win the fight. This stealthy characteristic of cancer cells makes them incredibly difficult to fight. Even when we develop effective drugs, cancer often finds a way to fight back. Imagine a world-class chess match. Our medical treatments make the first move, but cancer, like a cunning opponent, often counters. This is the conundrum of drug resistance. In a nutshell, drug resistance occurs when cancer cells learn to outsmart the medications designed to kill them. Seems unfair, right? But how does this happen? Well, each cell in our body, including cancer cells, has the ability to mutate. These mutations are essentially changes in the cell's genetic blueprint. Sometimes these changes are insignificant, but other times they can make the cell resistant to the drugs. It's like the cell suddenly finds a shield that deflects the drug's attack. This is a natural survival mechanism of cells, but in the case of cancer, it's a mechanism we wish didn't exist. Now let's get more technical. When we administer a drug, it targets specific proteins in the cancer cells. However, mutations can alter these proteins in such a way that the drug can no longer recognize or interact with them. Consequently, the drug becomes ineffective. Moreover, some cancer cells can increase the production of certain proteins that help pump drugs out of the cell before they can do their job. Think of it as the cell installing high-speed exit doors for the drugs. And it doesn't stop there. Some cancer cells can even go into a sort of hibernation mode, slowing down their growth and activities. Since many cancer drugs target rapidly dividing cells, these hibernating cells can evade the drug's attack. Unfortunately, this is not a rare occurrence. Many cancer patients who initially respond well to a drug later experience a return of the disease that is now resistant to that drug. This is why multiple drugs are often used in combination in cancer treatment to reduce the chances of resistance. So the battle against cancer becomes a constant race against time and evolution. As we've seen, there are many reasons why cancer is so hard to beat. The inherent complexity of cancer, with its myriad of types and subtypes, each with their unique set of characteristics, creates a challenging landscape for treatment. We've delved into the cunning nature of cancer cells, their ability to evade our immune system's defenses, and their propensity to develop resistance to drugs, further complicating the task at hand. Despite these challenges, it's important to remember that we're making strides in understanding and combating this formidable adversary. With the advancements in medical science, we're continually discovering new treatments, improving early detection, and enhancing our knowledge about the disease. The fight against cancer is indeed a tough one, but it's a fight we're not backing down from. While the fight is tough, the progress made in recent years gives us hope for the future. Beating cancer is a puzzle we are yet to solve, but every day we are putting more pieces into place.